Unit 2, Part 1. So in this unit, we're going to be talking about measurements as well as how to solve different problems. So what are units of measurement? So they're defined as physical quantities of a defined size. So what does that mean? If we want to measure something, whether it's temperature, whether it's mass, whether it's weight, we have to define how big a unit is going to be. So for instance, let's use the foot. Everybody knows doing measurements in length using the foot. The foot is 12 inches. We know that it's the defined size. And anything that's measured in feet, another person with a ruler can see how big a foot is. And we know approximately how large it is. So a foot is a standard that we use to measure length. So we use this for different physical characteristics or physical quantities. Now, scientists, because they want to be able to talk to other people around the world and understand what they're talking about, when they make quantitative measurements, they've decided to use the International System Units, the SI units. So these are units agreed upon by scientists from around the world, and they have standards of measurements that they use. Standards measurements are objects, and I should have put or natural phenomenon of constant value, easy to preserve and reproduce, and practical in size. And there are 7 SI units, which are fundamental units or base units. And we're not going to use all these, but we'll cover them so you're aware of it. So the length, the SI unit for length is the meter. And so the international standard for the meter is the distance light travels in a vacuum during a time interval of 1 over this number right here of a second. Okay? So if you look, it is 299,792,458th of a second. So we're talking about a very small amount of time that light would travel. It used to be that they actually had a piece of metal that was agreed upon as 1 meter in length. However, believe it or not, the size of a piece of metal will change over long periods of time. So it's not a reliable way of having a standard unit. So they use the distance that light travels. Okay, mass. The SI standard unit for mass is the kilogram. And if you remember from our previous unit, kilo means 1,000 and gram is the unit for mass. So kilogram is 1,000 grams. Previously, the standard for the kilogram was a platinum iridium cylinder kept in the International Bureau of Weights and Measures in the French town of Servais. But in 2019, so this happened recently, it was changed. It now is based on a physical constant called the Planck's constant. Temperature. The SI standard unit for temperature is Kelvin. And it's named after a Lord Kelvin. So because it's named after a person, it's always capitalized. And we don't say degrees Kelvin, we just say Kelvin. So water freezes at 273 Kelvin. We don't say degrees Kelvin, we just say Kelvin. And boils at 373 degrees. I did it. 373 Kelvin. Now you can see there's a 100 Kelvin difference between the freezing point and boiling point of water. And you may have heard of absolute zero. Absolute zero is 0 Kelvin. And scientists have not reached 0 Kelvin. It's theoretically impossible because in order for something to be at a temperature of 0 Kelvin, there would have to be no kinetic energy at all. In other words, electrons would have to stop moving. So theoretically, it's impossible. Scientists have come very close, but never achieved it. An electric current This is the SI standard unit for electric current, is the ampere. And when you take, or if you take anatomy and physiology, and you talk about muscle impulse, you're going to talk about milliamps. So you will see that in anatomy and physiology. Time, the SI standard for time is the second. And it's based upon the duration of 9,192,631,770 periods of particle radiation emitted by cesium 133 atom. Okay, so those are our units. Now these are fundamental units. Okay, these 5 right here. Now we have some derived units. So one is a derived unit is a unit that can be attained from the combination of 2 or more fundamental units. So if we use 2 or more of these units up here, we can actually have a derived unit. So in order, if you look at that, one of the things we need to look at is volume. Volume is defined as the amount of space occupied by an object. The SI standard unit for volume is the cubic meter. Okay, and so a common unit for volume is the liter, which is the volume equal to 1,000 centimeters cubed, and there are 1,000 liters in a cubic meter. So if we look at volume, if you see it's meters cubed, so the n cubed. So in order to get the volume of something, let's say you had a box, or I should say a box, and it was 3 meters tall, 3 meters deep, and 3 meters wide. To get the volume of that, so the volume of that cube, you would have to go 3 meters times 3 meters times 3 meters. So 3 times 3 is 9, and 3 times 9 is 27. So that box would be 27 meters cubed. So that's a derived unit because you're only using a length, but you have to multiply it times itself 3 times in order to be able to get the volume of an object. Okay? Density is defined as the quantity of matter in a specific volume. Density can be calculated by dividing the specific quantity of mass by the volume it occupies. Okay, so our formula for density is density equals mass divided by volume. Okay, let's take a look at this for a second. So let's look at the rest of this. So when the density of a substance is given, the temperature at what is measured is given. Density is sometimes determined as a ratio between a standard density of something, such as water, to that of another substance. For instance, density of water can be compared to the density of another substance. If the substance has a specific gravity greater than 1, it has a density greater than 1 for water. So let's say, what does this mean? Well, first of all, if I have, let's say, water at room temperature, let's say 70 degrees Fahrenheit, it is 1 gram per milliliter, or centimeters cubed. They both are the same. So what I could do is I compare the density of another substance. Let's say lead, right? Lead is greater. I don't know the density offhand, but lead is greater than 1. So it's greater than 1. So what I could say is that for comparison purposes, I could say that lead has a density, let's say it's 8 times as dense as water. So I could say that it has a density greater, 8 times greater than water, right? Because I'm comparing it to it. And if I know that, if I put it in water, I know because it's greater than water, because I'm comparing it to it, it would sink. Okay? So we could also say specific gravity. So water has a specific gravity of 1, because we're going to use that as a comparison. We could say, let's say lead is 10 times as heavy as water. So we could say its specific gravity is 10 times as much as that of water. Okay, I hope that makes sense. But let me know during the live session if you're not sure about that. Now, next is if we're going to convert between units, we can use a certain methodology for this. So the factor label method is a way that you can do that. And I'm just going to go over briefly here, but what I'm going to do is I'm going to start a second unit. In that second unit, what I'll do is I want to go over factor label method in much more detail. Okay, so I'm just going to cover it here briefly. So conversion between units. We can use the factor label method to do this, right? And so factor label method is a problem-solving method based upon treating units in calculations as if they were algebraic equations. And when we do this, we use conversion factors. So number 5, conversion factors. It's a ratio derived from the equality between 2 different units and can be used to convert from one unit to another. What does that mean? Well, let's say that I want to convert between different units in time. What I can say, or say some conversion factors we could use, for instance, is there's 60 seconds and 1 minute. So this could be a conversion factor. What is a conversion factor? When you look at a conversion factor, the top and the bottom, so the numerator and denominator, they're equal. They're in different units, but they're equal. So for instance, there are 24 hours in a day, one day, right? So they both are the same amount of time. I'm just using different units. Or I could write it as 1 day over 24 hours. Okay? So all you need to know right now is that conversion factors, we use them to convert from one unit to another. And each conversion factor itself, so this will be a conversion factor, the top and the bottom, the numerator and denominator, they both are equivalent, but they're in different units. Why are they different units? Because we can use it to convert from one unit to another. So let me just give a quick example. And I'm going to give an example which I know you can do without doing any conversions, but I'm doing this so it's easier to see. So let's go to a look blank page. And so if we have density, we said it's mass divided by volume. And so if I have an object, and the object is, let's say it's 10 grams, and let's say that it is, we'll say 5 liters. Okay, so if we divide 10 grams by 5, right? 5 goes into 10 2 times, 2, and the mass is units, grams per liter. So it's a derived unit because you're dividing grams by liters. All right, and we can use different I could use multiples of the mass. In other words, if I wanted to, I could have 10 kilograms. And I said liters over here. It could be milliliters or kiloliters. We'll say deciliters. Okay? So if I say 5 deciliters, I divide 5 into 10, it goes 2. And so it'd be kilograms per deciliter. Okay? So whatever unit I use, let me erase that part right there. Whatever unit I use when I do a density, right? Whether I use grams, whether I use kilograms, deciliters for volume or deciliters for volume, right? I could use millimeters cubed for volume. I could use milliliters for volume, right? Whatever units I use in my formula, those are going to be the units that I have when I talk about the density, all right? Because density is always the mass divided by the volume, okay? Okay, and actually, let me erase this. Let's say that I want to show using mathematically how I would convert from seconds to days. Okay? So I want to ask, the question is, if I have 24,000 seconds, how many days is this? Okay? So what I'm going to first start with is, my given is I have 24,000 seconds. All right? And I want to convert that to days. But first what I'm going to do is I want to convert it to minutes first. So there are how many seconds in a minute? So there are two conversion factors I could use. I could use 1 minute over 60 seconds. Or I could use 60 seconds over 1 minute. Now, I want to get rid of seconds. So if I look at these two units, either this conversion factor here, 1 minute over seconds, or 60 seconds over 1 minute, which one of these would actually cancel out the seconds? So I want the seconds in at the bottom. So I'm going to put 60 seconds here. Why is that? Because by dividing seconds into seconds, they cancel out. Okay? So I'm going to use this conversion factor, 1 minute over 60 seconds. Now, seconds will cancel. I was going to leave it minutes. So I'm going to cancel these out. Now I can use another conversion factor because I want to go from minutes to hours. Okay? Because I want to get to days eventually. So I'm going to multiply it times a conversion factor that will cancel out minutes. So I have two conversion factors I could use. All right? We know there are 60 minutes in an hour. All right? Or we could say we have 1 hour 1 hour. Made a mistake there. Right? There are, in 1 hour, right, there are 60. Okay? which of these conversion factors, this one here or this one here, is going to actually cancel out my minutes, right? Do I want a numerator or denominator? So I want the minutes are up at the top. I want them on the bottom. So I'm going to use this conversion factor here. So I'm going to multiply this times 1 hour over 60 minutes, right? And by doing that, I'm going to cancel out minutes, and it's going to leave my hours, which is what I want. Okay, so let's do that. So minutes are here and here, so they're both numerator and denominator, so they cancel out, and I'm left with hours. Now I want to get to days, so I need to go do one more conversion, use one more conversion factor. So how many hours are in a day? There's 24. So I can say 24 hours over 1 day, or I can say 1 day over 24 hours. So which one of these is going to cancel out the hours and leave days? So if I use this conversion factor, the hours are both in the top. It's not going to cancel out. Here, the hours are on the bottom, right, and the top, so they're going to cancel out. So I'm going to use this conversion factor. So I have 1 day over 24 hours. The hours are going to cancel out. I'm left with days. Now I can multiply them and divide the 24,000 by however 60 times 60 and 24 is. So let's try that. Let me erase this first. All right, erase this. All right, now let's do 24. So what I'm going to do is I'm going to multiply 60 times 60. So 60 times 60 equals 3,600 times 24 equals 86,400. So if I have 24,000, right, days, and I'm going to divide that by 86,400. All right, so what's 24,000 divided by 86,400? So let's do that. 24,000 divided by 86,000. That gives me 0.279. So it equals 0.279 days. So you can see that 24,000 seconds is about a little bit more than a quarter of a day. Okay? And again, I'm going to do another unit and go over some more of this because I think factor label method is it's something that's important, but it takes some practice.